Looking at the world around us, it's amazing to see its geographic diversity. Even more amazing is the way mankind has invented technologies to meet nature's challenges. Even something like winter evokes different imagery globally. In many Western European countries, for example, winter temperatures remain near or above freezing, and the roadways are often dry or covered with rain and melting snow. In Eastern Europe, Asia, and North America, on the other hand, winters are harsher, with below freezing temperatures and ice or snow-covered roads. These varying conditions have dramatically shaped the manufacturing of winter tires. In fact, the global contributions of engineers have led to three main types of winter tires, each suited to the local conditions drivers face. The first, winter performance tires, or lamellin tires, are popular in areas like Frankfurt, Germany, where winters are mild and wet. Here, high-speed stability and wet performance are of utmost importance. The second, studded tires, are popular in areas like St. Petersburg, Russia, where winters are icy and snowy. Here, maintaining traction in freezing temperatures is most important. The third, studless tires, were originally developed for areas like Hokkaido, Japan, where environmental and social concerns banned the use of studded tires, but are now popular in areas with harsher winters like the northern United States, Canada, and Eastern European countries. Here, maintaining the traction of a studded tire without using pins is most important. Looking more closely at each location will allow us to understand how today's winter tires are able to handle varying types of winter driving conditions. Each year, winter weather accounts for hundreds of thousands of accidents in the U.S. alone. That's why vehicle manufacturers spend countless hours engineering cars to be safe and reliable in winter. Fog lights, adaptive headlights, safety belts, and traction control are just a few vehicle technologies improving driving safety. Your tires are a critical element in the winter safety equation. After all, it's these four tires that keep the vehicle carrying you and your family connected to the road. Just like vehicle manufacturing, tire technology has continuously improved over the past few decades. Many of the major innovations in tire manufacturing have come from decades of weather observation, which has allowed manufacturers to tailor tire designs for specific winter conditions. Specifically, the technology and performance that is optimized for near-freezing conditions is significantly different than tires optimized for below-freezing conditions. For regions where temperatures remain near or above freezing, and the roadways are often dry or covered with rain and melting snow, winter performance tires or lamellin tires are engineered for driving at higher speeds. For areas with harsher winters where temperatures are below freezing and ice or snow covers the roads, studded and studless winter tires are engineered to operate at lower temperatures and provide greater snow traction. Areas of the world that use winter performance tires often have light snow and rainy conditions and highways that allow travelers to drive at higher speeds. The key to safely driving in these conditions is tire stability. This is done through tread design. Both the shape of the tire and the individual tread blocks are important. Winter performance tires tend to have a rounder profile, which is better for wet performance. Additionally, winter performance tires have larger, solid tread blocks that are more rigid and keep the tires stable at speed. But there's a catch. If the blocks are too large, acceleration and braking on winter roads can be challenging. Engineers address this by adding sipes. Sipes are thin slits in a tread block that increase traction in snow and wet weather. Modern sipes come in many shapes and sizes and are designed for different performance characteristics. The sipes on winter performance tires are designed to provide traction without sacrificing block rigidity, which is a top concern when engineering tires for high-speed endurance. To achieve this, engineers add sipes laterally into the tread blocks, which provide forward stability and give these tires their characteristic look. Winter performance or lamellin tires are named after their sipes. Lamellin comes from the German word lamella, which describes the layout of the sipes positioned on the tire. Engineers continuously develop winter performance tires. They analyze and adjust the tire's compound, construction, tread depth, tread pattern design, and siping arrangement to improve tread block rigidity for safe, wet winter driving. Unlike mild winters, harsher winters tend to have lots of ice and snow. People living in these conditions gladly give up high-speed stability in order to gain ice and snow traction, resulting in the development of both studded and studless snow tires. Historically, the best option for winter traction was studded tires. Like a golf cleat, studded tires have metal or aluminum pins that dig into ice and snow to gain traction. Initially, the pins were unsophisticated and simply drilled onto an existing tire. Now, the shape and positioning of the pins are purpose-designed for more effective ice traction. In extremely cold conditions, engineers are also concerned the tire compound will harden and lose traction. Imagine an effective pencil eraser that conforms to the surface of the paper versus an ineffective hard eraser that slips and can't generate enough friction to erase. Like an eraser, a tire needs to conform to the road surface to gain traction. If the tire hardens easily at cold temperatures, it won't be effective. Nitto solves this by adding silica to the tire's compound, which prevents hardening with its low freezing point. It conforms to the road surface for better traction at freezing temperatures. In areas where the snow and ice continue through winter, studded tires remain popular today. Studded tires aren't perfectly adapted for every region, as the pins can dig into the road instead of ice, causing road damage and pollution when ice has melted. In fact, in Japan, studded tires were causing serious respiratory problems and traffic delays from construction. The financial burden of rising healthcare and road repair costs, as well as frustrations from increased traffic congestion, led the Minister of the Environment to pass the Act for the Prevention of the Occurrence of Spiked Tire Dust in 1991 that prohibited the use of studded tires. However, taxi drivers of the Hokkaido region, located in northern Japan, demanded a tire that would still provide enough winter traction to climb the steep hills in the area. This challenged tire manufacturers to develop studless tires that would perform on this demanding terrain and meet these high expectations.
Sapporo's weather is very unique. It gets warm during the day, but gets really cold at night. Warm during the day and cold at night. This pattern repeats, so the snow surfaces are compacted when they freeze. The tires slip on the frozen surfaces, polishing the ice and making it even more slippery. These surfaces are so slippery that you can't even walk on it. Well, it may be a funny way to say this, but the first studless winter tires were thought of only as a slight improvement over the snow tires. They didn't perform well on ice. For the first 5 years, you would see people with chains on their studless winter tires, driving around all doubled up. It was pretty common to see that. A lot of people would say, studless winter tires are useless. The lamellan tire performs okay on the snow, but once the snow becomes ice, it slips. Once it slips, it continues to slip. So if I want to drive with some grip, I have to drive slowly. Even if I'm driving slowly, I feel a lack of confidence. But if I'm driving too slow, it won't go up hills. I want to go up the hill with some momentum, but it'll slip if I drive faster. There are a lot of issues. If it doesn't go uphill when I need it to, I won't be able to get to my customers' destinations. And if it doesn't stop when going downhill, there'll be accidents. Either way, I need confidence that it'll perform well on ice. It's difficult to use tires that perform well in one condition, but don't do well in another.
How do tire manufacturers engineer studless tires capable of providing traction only before found on studded tires? Nitto uses pioneering out-of-the-box thinking and innovative materials to create studless tires that are optimized for snow and ice performance. And since they were engineered for use in one of the harshest winter regions in the world, today they are popular throughout the U.S., Canada, and Eastern Europe, areas where winters are wet, icy, and have snow-covered roads. Nitto made 3 major improvements to its winter tire technology to increase traction. Many of these improvements come from an unlikely source, nature. Nitto sought inspiration from naturally occurring and abundant materials like walnut shells and bamboo charcoal to gain traction. First, Nitto infused walnut shells into the tire compound. This unconventional material acts like mini studs that create a scratching and digging effect on ice and snow for additional traction. Second, Nitto added bamboo charcoal into the tread compound. This porous and sustainable material works like a sponge to soak up the thin film of water on icy road surfaces, which adds traction. The last and most important is the tread design. Getting the tread pattern just right used to be a guessing game. Now, with computer modeling, Nitto can quickly and safely develop hundreds of designs and test them in virtual environments, simulating different conditions. The best designs are then real-world tested to verify their performance. Your tires are safer as a result of this technology. Nitto has revolutionized the tire design process, optimizing one of the most important winter tread features for studless tires: siping. Studless tires have far more sipes than winter performance tires. Even though adding more sipes can make the tread blocks more susceptible to flex, the benefit of ice and snow traction far outweighs the loss in this trade-off. In fact, Nitto's 3D multi-wave sipes give the best of both worlds: stable handling performance with less tread flex. The secret is the interlocking ripple design, which allows the sipes to lock together while still providing added traction. These work in unison with Nitto's 3D interlocking sipes, which increase traction when accelerating and braking on snow or ice. Nitto met Japan's tire challenges by rethinking the way tires are built. Unique materials like walnut shells and bamboo charcoal improve winter traction and make it safer for you and your family to drive in winter conditions.
When I have the studless tires on, they grip the surface, even if it's frozen. It's quite a big help. It'll go uphill, so I can drive with some confidence. Many of the customers that live in hilly areas have told me taxis won't be able to go up the hill, and then tell me alternate routes. But sometimes I'm able to go up the hill with my driving skills, and they would tell me, "You're the first one to go up this hill." Either way, I'm not able to do that if my tires don't perform well. I'm really thankful for the performance of the tires. But now, if I were to review the studless winter tires, I would say that their performance has drastically improved, and it's a completely different tire. Even on these slippery surfaces, the studless winter tires do their job. I am really impressed with modern technology.
These advancements in tire design and materials are found in Nitto's winter products. Nitto's commitment to innovation and manufacturing excellence ensures that Nitto will be on the forefront in tire development and always keep your safety a top priority.